Hello, dear students. This is your science teacher, Mrs. Tasneem Atif, and I'm happy to be with you today. Today, inshallah, we're gonna explain the last lesson of Unit 1, which is Lesson 3. Lesson 3 speaks about the chemical evidence and salts. Chemical evidence. Addition is performed. Sulfuric acid, the center of table sugar, turns it charred, which indicates its danger. Therefore, it's absolutely forbidden to taste, smell, or touch any chemical substance in lab without teacher's permission, as we've mentioned before, because there is corrosive acids, which are concentrated one, and of course caustic alkalis. If we can't identify chemicals such as acids, alkalis, solution by taste or smell, so how can we differentiate between them? How can we distinguish between these materials, like acidic materials and alkaline materials? And of course, what about the neutral materials? Concluding from above, to distinguish between acids and alkalis and of course neutral materials, like distilled water, is done using by chemicals called indicators. So if we wanted to differ between all of these materials without smelling, tasting, touching, we can use indicators, which are substances that change color in acidic medium on alkaline medium, such as the sunflower dye guide that goes into making litmus stripes. Distilled water, neutral, or has neutral effect that doesn't change or affect the litmus stripe or the litmus paper, as the number of ions of a positive hydrogen is equal to the number of ions of hydroxide ions. The sunflower guide is not suitable for distinguishing between strong acids and weak acids because they always have the same color. There are many other indicators beside litmus papers or litmus solution. The most famous of these is the universal indicator, which comes in the form of dye or stripe, which can distinguish between acids and bases, and of course weak acids and strong acids, weak bases or alkalis, and the strong bases or alkalis. So it can differ between them according to their strengths. Okay, pigments are extracted from some plants to be used as guides according to the following table. So these are the dye color, and of course the dye colors, and these are the dye colors in acids, the dye colors in alkalis. Acidity and alkalinity test. Evidence stripes must be wetted with water when testing acid gases like carbon dioxide or basic gases like ammonia NH3 to dissolve it. In general, evidence only works in the presence in aqueous medium, so they have to be wet. Gaseous elements such as nitrogen, oxygen, hydrogen don't change the color of indicators except chlorine gas, which removes the color of the litmus stripe. As you can see in front of you, it erases the color from the litmus stripe. Integration with agricultural sciences. The color of hydrogen flowers varies depending on the type of soil. The flowers turn red when planted in acidic soil, while they turn blue when planted in alkaline soil, as you can see in the picture in front of you. Medical application. acidic soil is treated by adding basic materials to it, like calcium hydroxide. Cross-cutting concepts, cause and effect. Most chemical indicators change color depending on the type of solution used. pH. The acidity of tomato is different from that of lemons. So, how can we accurately determine their acidity or the different levels of acidity? The acidity and the basicity of solutions is determined by what's known as pH, which is symbolized by the symbol pH, which is a scale graduated from 0 to 14, like we've mentioned before. As you can see in the scale in front of you, from 1 to 6, we're dealing with the level of acidity, or those are the types of acids, starting from the strong acid reaching weakest one. And then in the middle, at 7, you can deal with only neutral materials like pure water. And then from 8 to 14, that's the basicity level. Starting from the weakest base or alkaline, reaching the highest or the strongest one at 14 on the scale. The value of is the pH of neutral solutions, and the distilled water is 7, like we've mentioned, while its value for acids less than 7, for alkalis greater than 7. The strength of acidic solution increases as the pH value approaches 0. So, once you come closer to 0, you're dealing with stronger acids. While the strength of alkaline solution increases as the pH value approaches 14. The pH values of solutions are measured directly and accurately using pH meter, or roughly using stripes of universal 1 or universal guide. By comparing the color of the stripe after immersing it in the solution whose pH value is to be measured with the model attached to the stripe package, in which each color represents a specific pH value. Right now, you can answer these questions. There are, or in front of you, you can find pH values or pH scale according to some materials. So, after studying it well, you can answer those questions. Okay, let's skip forward for the next point. Here, a live application. The pH values of skin and hair care products differ, as the pH value of the shampoo used to clean dry hair is different from that used for cleaning oily hair. And all of this according to the pH scale or pH values. Now let's enter new part, speaking about salts. A salt molecule can be formed by combination of metallic ion and non-metallic ion, except for the negative oxygen. And what is the ion? The ion of an element. It is an ion of an element and an ion of the atomic group. So we have two types of ions, either to deal with the ion of the element, either it is positive ion or negative ion, cation or anion. And there are other ions of atomic groups, as we have positive atomic groups like ammonium group, and we have negative atomic groups like we've mentioned before, hydroxide group, carbonate group, nitrate group, nitric group, and so on. Except the hydride and oxide group, which is hydroxide, OH negative. The two ionic atomic groups we have mentioned before. When the same atomic group is repeated in the molecular formula of a compound, the atomic group is written between brackets, and below it the number of that indicator of the number of repetition. The name of a salt begins with the name of the anion. We start in the salt by anion, followed by the name of cation. As you can see, salts consists of, we have two sides or two sections. Positive atomic group anion, positive metal group anion. Number one, or the first part, with negative atomic group with negative nonmetal ion. Here, ammonium sulfate like NH4 2SO4, or ammonium chloride like NH4Cl. So the atomic group can be reacted with non-metal, or it can react with another atomic group. Another example, ammonium nitrate NH4NO3, or ammonium bromide NH4Br. Those are the two ways for reaction or formation of salts according to combination of two atomic groups or one atomic group with a nonmetal. Okay, what about the other side? Positive metal ion with, okay, let's start by the first one. Okay, negative atomic group with metallic ion or positive ion of metal, like sodium sulfate Na2SO4, or magnesium carbonate MgCO3. So here, combination between atomic group and cation of the metal. On the other hand, you can find reaction between cation of a metal with anion of non-metal, like sodium chloride NaCl or sodium sulfide Na2S. The properties of salts, the salts vary as they differ from each other in the term of color, water solubility, and pH values like we've mentioned before. Salt solids, some of which are white in color, such as zinc sulfate, and salt like sodium carbonate, and some colorful like copper sulfate, blue color, and nickel chloride salt in green color. Some salts dissolve in water, forming solutions such as copper sulfate and nickel chloride. Also, all salts, sodium, potassium, ammonium, and nitrates, some of which are insoluble in water, like silver chloride and calcium sulfate, and all salts of carbonate except sodium, potassium, and ammonium carbonate, they dissolve in water. So here we have comparative table to differ between salts that don't dissolve in water and salts dissolve in water. Integration with basics. The salinity of water is considered the Dead Sea. Okay, so we here dealing with the salty level of water in the world about 10 times from the salty water of the Red Sea. Therefore, it is not possible to drown in the Dead Sea water according to the level of salt in it, as it has high percentage of salts in the water, leading to increasing its density. So it's not possible to drown in the Dead Sea. It's clear from above that salt solutions may be acidic if it is lower than 7 according to pH scale, such as ammonium chloride solution. It could be neutral, which is equal to 7 in pH scale, like sodium chloride solution, or alkaline 1 if it's higher than 7 in pH scale like sodium carbonate solution. Acid and alkaline solutions are similar to salt solutions. The mixtures of salt dissolve in water and its melting pots, molten salts, and the conduction of electrical current. Solid salts don't conduct electricity, and neither does distilled water. It doesn't conduct electricity too. Here in the table, the common name and chemical formula for different salts. How can we distinguish between sodium chloride and silver chloride? By adding a little water to each of them and stirring or shaking it well. We notice that sodium chloride dissolves in water while silver chloride doesn't dissolve in water. Thank you so much. See you soon in new video. Goodbye.